right, so in this video and in another video, we're going to cover the phases of the moon and make sure that we know, in this video we're going to go through the basics, the terms that we're going to think about, the order of the moon phases, some of those introductory ideas. And then the next video that we have, which will be in the next week of material, will focus on some of those lecture tutorials that can help us think through both what's causing the moon phases, making sure that we really do have a good sense of that, as well as being able to predict the order of moon phases, thinking about how long they take and the order that they go in. So an initial pause and think question for us to ponder. Based on your understanding before this class, so before this video, before the other video having to do with the moon, what would you say is the reason that the moon has different phases? So read through these options, pause the video once I finish this sentence, and think about what you know from before this class. Okay, so the most common incorrect answer is obstruction by the Earth's shadow, the second choice here. We're going to learn next week, in a couple of videos from now, exactly what specific celestial event happens when the moon goes through Earth's shadow. But it's something that is fairly rare. It can only happen up to twice a year or so, and isn't the reason that we have all of the moon phases every single month. And if we pay attention to the moon when we see it up in the sky and the shape that it can take, it's impossible for the Earth's shadow, which is going to be a circular kind of shadow, it's impossible for that to be the reason that we have phases. But it's a very, very common misconception because we don't spend that time looking up in the night sky. And so hopefully over the course of this semester and beyond, we start to. Now, the answer here is 3, and our big goal for this video and for the next video is to really get to the heart of why those various alignments cause the phases. Before we start to even talk about the moon at all, let's make sure that we can understand this top-down view of Earth. So first of all, what we're looking at is a person, and let's imagine that they're standing at the Earth's equator. And as the Earth rotates every 24 hours, the person goes around in 3D space through all of the different directions that we see here: noon, sunset, midnight, sunrise. And we're looking down at the North Pole, which means we can't have any compass directions here, because for each one of these 4 giant people that we have drawn on our slide, for all 4 of those people, north would be towards the center of the circle that we're looking at. And so we can't think about compass directions out in space. They just don't work. Now, the reason that, if we look at the reason that the person here is labeled noon, is because the sun is coming in from the right side of our picture here, and it's shining high in the sky for that person at noon. It might not be directly overhead. That isn't the case every single day of the year, but it will be the highest that it can get. As the Earth rotates, and we see here that it rotates counterclockwise by looking at the top down, that counterclockwise idea isn't something we have to memorize, and it isn't something that there's a specific reason for. It had to pick one way or the other. And what we'll see is that counterclockwise idea is something that is true for all of the planets on their axes except for Venus. And the moon going around the Earth is going to be counterclockwise, and then all of the planets going around the sun are all counterclockwise. And that comes from the conservation of angular momentum. The initial cloud that all of this stuff formed from was moving counterclockwise. Okay, so we don't need to have that memorized, but once we have established that from noon the person is going to start rotating towards the top of our picture, then we think about our clock time, and noon turns into 1 p.m., turns into 2 p.m. And eventually, the person goes from being on the day side of the Earth, the part that's lit up on our screen, to the night side. And by definition, when it goes from daytime to nighttime, that's happening at sunset. And then as the clock continues to march forward and the Earth continues to rotate, midnight happens when we're furthest away from the sun, when the sun is as far as it can be from both sunset and from sunrise. It's on the exact opposite of what we would call noon, and that's when we would see all of the constellations for that particular time of year. That's when we would see them high in the sky, the seasonal constellations. Then as the rotation continues and the clock moves forward, midnight becomes 1 a.m., becomes 2 a.m., and eventually we go from the nighttime side of the Earth to the daytime side of the Earth. And by definition, when we're going from night to day, that's happening at sunrise. And so we call that sunrise. Now, over the course of this portion of the chapter, we're going to just approximate sunset to be around 6 p.m., the in-between noon and midnight. And we're going to approximate sunrise to be 6 a.m., between midnight and noon, just for ease of being able to think through this. Okay, so if you haven't yet, maybe take a moment, pause the video, and copy this into your notebook and have those explanations for why noon is on the right. And it's only because we've put in the sunlight on that side of the diagram. And then the rotation of the Earth bringing us from noon through sunset to midnight to sunrise and again back to noon. Okay. So the terms that we're going to be using throughout this portion of the chapter are all listed on this slide. All of the terms that we need to use when we're talking about moon phases. So the full moon is the thing that people are most familiar with. So the full moon is very easy for us to spot because it's visible from sunrise, from sunset when the moon rises until sunrise when the full moon sets. That isn't true for every single moon phase, and that's something that we're going to confront, not in this video, but in the next one, that moon phases rise and set at different times of day and different times of night, and the full moon is just one that's in the sky for the entire portion of what we call nighttime, and so it's very easy to spot once we're looking for it. The new moon, when we're looking at it from Earth, we can't see it at all. We're looking towards the new moon, and if we look at it over here, we're looking towards the new moon, and what we see instead is nothing at all because it's the dark side of the moon, so nothing's lit up, and the new moon is up during the daytime. It rises with the sun at sunrise, and it sets with the sun at sunset, and so it's impossible for us to actually see. The quarter moon is the way that we refer to when we're a quarter of the way around the set of phases. So new moon we can treat as the sort of start of the circle or the 0th quarter. And so first quarter is once we've rotated 1/4 of the way around the circle. And that's something that a lot of students struggle with, that a quarter moon doesn't look a quarter lit up. It's a half circle from our point of view. The quarter refers to the portion of the full circle of moon phases. Full moon then we could call second quarter. No one really does, but it wouldn't be incorrect to think of full moon as second quarter. We've made it halfway around. And then from full moon we go to third quarter. So 3/4 of the way around the circle becomes a third quarter moon. Again, it looks like a half moon with the other side lit up from our point of view. And then we go back to new moon, which we could then even call fourth quarter if we felt like it. In between these phases, every single night and every single day, the moon is transitioning from new moon to first quarter to full moon to third quarter to new moon. But it's out in the sky every single day, every single night, depending on when we're able to see it, when it's above our horizon. And so for several days at a time, it's going to have a shape that we'll call a crescent shape. And that crescent shape is one that we're familiar with from other terms of the other uses of the term crescent, like crescent rolls, and that crescent shape we're used to thinking about. Gibbous is a shape term, the way that crescent is, but it's the opposite. It's a shape, a circle that is more than half lit up. And so we'll see that in the deeper look video when we see what that shape actually looks like. And then waning is a term that we're going to see not in this video, but in the next one, where waning by definition refers to an object becoming progressively less illuminated from our point of view. So full moon, the moon is as lit up as it can get from our point of view, and over the next 2 weeks, it's getting less and less lit up from our point of view, and so we would call it a waning gibbous, and then we would call it a waning crescent as it went through those phases. And then on the opposite face of that, waxing refers to something that is getting progressively more illuminated from our point of view. And so a new moon, we don't see any of that moon lit up. And so over the next 2 weeks, as we see more and more of the lit up side facing towards Earth, then it's a waxing crescent when it's only a little bit lit up, and then a waxing gibbous once it's mostly lit up. So after this video, it will be worth your time to find the deeper look video for moon phases, whether that's in this week, week 3, or in week 4, and go through it and make sure that we understand what those terms mean and what those phases look like. We'll be going through those piece by piece. Now, if we take a step back, quite a few steps back, we can think about what this photo is showing us. This is an image taken by the Apollo 8 mission. So one of the many missions that we sent towards the moon. We didn't actually land on the moon yet at that point in 1968. But as the Apollo spacecraft was coming around the backside of the moon, the Earth came into view and they snapped this photograph. And so what we're looking at here is the Earth, and we can see that it's not a full circle. Some of it looks dark. And that dark part, people living on that part of the moon, or on that part of the Earth, would say that it's nighttime. That's what that dark part means. And the part that we see all lit up like that, sunlight is shining on that part of the Earth, and we would call that daytime. We also see that the shape that we're looking at is a little bit more than half lit up, more than a semicircle. And the shape that we're seeing here is a gibbous shape. So that word that we're starting to get used to, the shape term, this would be a gibbous Earth if we were living on the moon looking at it. So we're comfortable with the idea that half of the Earth is always lit up, that's daytime, and half of the Earth is always dark, nighttime. But those halves keep shifting as the Earth rotates on its axis every 24 hours and moves through its orbit over time. The same thing is true on the Earth, or on the moon as well. Half of the moon is dark and half of the moon is lit up. They're day side and night side if we were to live there. The question then becomes, is there one single side of the moon that is always lit up or always dark? Because there's this phrase, dark side of the moon, that is sort of pervasive in popular culture, and so we'll think about that briefly. But if we think about the Earth, as the Earth rotates, we have, on our clocks, we have sunrise, and then noon, and then sunset and midnight, and any single part of the Earth's surface is going through the daytime and nighttime, and there's not a single side of the Earth that is always lit up. So, in order to really answer whether the moon has a single dark side and single bright side, we have to think about what it is that we see when we look up in the night sky. So let's look at the following 4 images, which are showing what the moon would look like from our point of view at different points in its cycle. And these are just representative of this. So the far left picture on our screen, that is a new moon. So we wouldn't actually see it lit up at all because the new moon would be out during the daytime and we wouldn't have this dark background to see it kind of lit up. But what we can notice is the patterns, the dark patterns. We'll learn later on in the course that they're called Maria. One of those is mare, which is Latin for sea. The dark parts of the moon's surface, we can look at that pattern Some people see like an upside down bunny rabbit kind of thing. Whatever pattern that you actually see, we can just think of what it looks like here. So if we were to build a house, let's say, on this crater right here where my cursor is on the screen. So we go to the moon, we build a house there, and for the new moon phase that we're starting out with, our house would be experiencing nighttime. By the time we get to a first quarter moon here, our house would be experiencing daytime. We would have sunlight on our house. Then at full moon, we're still experiencing daytime for where our house is, where we chose to build it. And then by third quarter moon, we're experiencing nighttime again. And so what we can see really clearly here is two different things. There's no single dark side of the moon, right? We built our house there. We experienced daytime and nighttime if we were to live on the moon there. But what we can also see is that the pattern that we're looking at stays the same over the entire cycle, over the entire month-long cycle of phases. Our house is visible from our point of view here on Earth for all of those 4 examples from the cycle and all of the in-between days. So is there one far side of the moon then? If we look at this set of pictures, we see that one side of the moon is always facing the Earth, which means there's one side of the moon that is always facing away from the Earth, a single far side that is always on the opposite side of our point of view. So that far side will experience daytime and nighttime, so there's not a single dark side of the moon, but it is fair to say that there is a single unchanging far side of the moon. So if we never get to see the far side of the moon, does it rotate? So pause the video briefly and think about that question. And if we think about it, we've got 2 examples here, 2 possibilities on our slide. In both cases, rather than building a house, we built a giant arrow-like monument, because why not? And in both of these cases, we're looking at the Earth-Moon system kind of at an angle, and that's why it looks so squashed like an oval. We're looking at it at an angle. In the top picture here, we built that monument, and it was facing Earth when we built it, here at the bottom of the circle. But then it's facing towards some distant star, and facing towards some distant star on the opposite side of the Earth from where we built it. And then it's facing that same distant star, and then it gets back around to actually facing the Earth again. Okay, so that's one possibility for what might be happening with the moon. On the bottom of the slide here, we have another possibility. We built that monument facing the Earth. As the moon rotated, it's still facing the Earth. As it rotates a little bit more and goes around in its orbit, that monument that we built is still facing the Earth. And then as it rotates more and goes around its orbit more, it's still facing the Earth. And then it comes all the way back around again. So if we compare what we saw with the unchanging pattern on the previous slide with these 2 possible realities, what we have to come to terms with is the fact that the moon does rotate. And it rotates exactly once for every revolution, for every big orbit that it makes. So from full moon when we see it until about a month later when we see the full moon again, the moon has rotated once on its own axis. Okay, so for this video, this introductory video that you should watch sort of before the deeper look video of moon phases, and then we'll confront more of these ideas of moon phases in a separate video. What we've gotten to so far is that when we see the moon lit up in the night sky, it's not making its own light. It is lit up by reflected sunlight the same way that the Earth is. So we saw the Apollo photograph of the Earth. It was lit up. The Earth isn't making its own light. That's just reflected sunlight. Then we confronted the fact that the part of the moon that is lit up, the part that is experiencing daytime at any given point when we're looking at it, that changes over the course of the lunar cycle. It's not a 24-hour change, but it is a change. So that means there's no single dark side of the moon. But we also figured out that the pattern that we see when we look up at the moon is always the same, which means there is a single far side of the moon. And it also tells us that the moon is rotating not really fast, not every 24 hours, but it's rotating once on its axis for each single full revolution that it makes around the Earth. And so the moon takes about 1 month to go around the Earth, and it takes about 1 month to go around its own axis. That isn't a coincidence. It's what's called tidal locking. So the moon is tidally locked to the Earth. And we can talk about that in the discussion boards if we want to. It's a topic that's a little bit outside the scope of this class, but it is an interesting topic and one that the book talks about a little bit. So we're going to end the video here where we've gotten through some of the key terms, and we'll see those key terms show up in the deeper look video, and then we'll see those key terms show up again in our other moon phase video. All right.